Right now, somewhere just behind your ears, a sound is arriving. Maybe it's the hum of a fan, or the settling of a house at night, or simply the quiet hiss that exists even in silence, the sound your own nervous system makes when there is nothing else to listen to. You didn't ask for that sound. You didn't choose to notice it, and yet here it is, folded into your awareness without any effort on your part, as though it had always been there, waiting. At the very same moment, your breath is moving. Air is entering through your nose, or perhaps your mouth, traveling down a passage lined with warm, moist tissue, reaching lungs that expand without your permission and without your attention, usually. You have taken something like 20,000 breaths today, and you were awake and thinking for almost none of them. And yet if I ask you to notice your breath right now, you can. It's there, available, as if it had been running quietly the whole time, like a pilot light in an old furnace, ready to be seen the moment someone opens the little door and looks. And your body, not just your breath, but the whole of it, the weight of your shoulders against whatever is beneath you, the very slight coolness of the air on any skin that happens to be exposed, perhaps an itch somewhere, small and forgettable, that only becomes real the instant your attention lands on it, and then vanishes again when your attention moves away, as though it existed only for the duration of your noticing. And underneath all of that, or perhaps threaded through all of that, there is thought, a drifting image, a stray sentence, the fragment of something someone said to you earlier today, replayed for no particular reason. Thoughts arrive the way weather arrives, without an obvious point of origin, without your having summoned them, and yet they feel entirely yours, entirely private, happening in some inner room that no one else has ever entered. Here is the strange part, the part worth sitting with for a while tonight, because it is the kind of strangeness that rewards slow attention rather than quick analysis. Sound, breath, body, and thought are not four separate experiences politely lined up and taking turns. They are not being reported to you one at a time, like messages arriving from 4 different countries. They are somehow all happening together, all at once, all inside a single unified sense of being here, now, in this moment. The hum of the fan, and the rise of your chest, and the weight of your shoulders, and the drifting fragment of a sentence are not 4 presentations. They are one presentation, one field, one experience that simply happens to contain all of them. This is worth pausing on because it is not obvious, and it is not something your senses were built to point out to you. Your eyes send visual signals along one pathway. Your ears send sound along another. Touch receptors in your skin send their own separate signals, traveling their own separate routes, arriving in the brain by entirely different roads, at entirely different speeds, having originated in entirely different places on your body. There is no wire running from your ear to your skin that says, by the way, whatever you're hearing right now belongs with whatever you're feeling right now, and yet, somehow, you don't experience 4 separate broadcasts. You experience one evening, one quiet room, one version of being you, right now, that has sound and breath and body and thought, all sitting together inside it without seams. Scientists sometimes call this the binding problem, and it has been sitting at the center of the study of the mind for well over a century. Back in the 1890s, an American psychologist named William James spent a great deal of time trying to describe exactly this feature of experience, the way it doesn't arrive to us in fragments, but as what he called a stream, continuous, flowing, each moment shading into the next rather than standing apart from it. He was not trying to explain how the brain accomplishes this. He was simply trying, carefully and patiently, to describe what it is actually like to be a person having a moment. That distinction matters, and it will matter again and again as we go along tonight. There is a difference between describing the mechanics of a nervous system and describing the felt quality of being someone at all. Both are worth understanding, but they are not the same project, and tonight we are beginning with the second one, because it is the one that is happening to you most directly, most undeniably, right now, whether or not you ever learn a single fact about neurons. So let's be a little more precise about what we mean by that word, consciousness, because it gets used loosely, almost carelessly, in everyday conversation. Sometimes people use it to mean simply being awake rather than asleep, as when a doctor asks whether a patient regained consciousness after surgery. That's a real and useful meaning, but it's a narrow one, mostly about the on and off switch of arousal. Tonight, we're circling something a little different, something closer to what philosophers sometimes call the felt quality of experience, or, using an old piece of Latin borrowed for exactly this purpose, the qualia of a moment. What it is like, from the inside, to hear that hum, what it is like to feel your own chest rise, not the measurement of it, not the explanation of it, but the raw, immediate, undeniable fact that there is something it is like to be you, hearing and breathing and feeling and thinking, all at once, right now. This is different from a tour of brain anatomy, and it's worth being honest about that difference from the very start, because a great many attempts to explain consciousness quietly slide into the other thing instead. They begin describing consciousness and end up describing the visual cortex, or the thalamus, or some loop of electrical activity, and somewhere in the middle, the actual experience, the felt presence of being someone, quietly disappears from the explanation altogether, replaced by wiring diagrams. Wiring diagrams are valuable. We will spend plenty of time with them across the nights ahead, because the brain really is an extraordinary object, and understanding its architecture tells us a great deal about how experience is even possible at all. But architecture is not the same as the view from inside the house. A blueprint of a house can tell you where the windows are placed and how thick the walls are, but it cannot tell you what it feels like to stand in the kitchen at dusk, when the light comes in low and gold across the floor. Tonight, and across the sections that follow, we are going to try to hold both of these things in mind together, the blueprint and the felt experience of standing inside it, without letting one quietly swallow the other. Notice, then, that this binding you're experiencing right now, this seamless togetherness of sound and breath and body and thought, isn't something you built. It isn't something you're doing on purpose. In fact, the harder you try to grab hold of it directly, to catch it in the act, the more it seems to slip sideways, the way a word can vanish from memory the instant you reach for it too eagerly. It seems to simply happen, continuously, quietly, underneath your deliberate attention, offering itself up as one whole moment, rather than a pile of separate parts. And that quiet, effortless togetherness is, in a sense, the most basic and most mysterious fact about being a conscious creature at all. Not the thoughts moving through it, not the sensations passing across it, just the fact that there is a unified, ongoing felt presence here to have them in the first place. Let your attention rest there for a moment, on nothing in particular, just on the fact of noticing it all. And as you do, let's turn gently toward an even older and more basic layer of that noticing, the sense, so easy to take for granted, that you are somewhere, in a body, in a place, and that this too has never once required your permission. That sense of somewhereness is worth sitting with for just a moment before we move on, because it turns out to be one small piece of a much larger puzzle, a puzzle that researchers have found useful to break into pieces of its own. Because when people say the word consciousness, they often mean several different things at once, the way a single word like love can mean the quiet comfort of an old friendship, or the sudden ache of missing someone, or the steady devotion between a parent and a child. Consciousness, too, turns out to be a bundle of related but separable things, and tonight it might help to gently pull a few of those threads apart, not to make anything more complicated, but actually to make it simpler, the way naming the different birds outside your window can make the dawn chorus feel less like noise and more like a conversation you can follow. The first thread is wakefulness. This is the most basic layer, and in some ways the easiest to picture, because your body already knows it intimately. Wakefulness has to do with a kind of physiological readiness, a general state of arousal that your brainstem manages largely without asking your permission. Certain clusters of neurons, tucked down in that ancient stalk of tissue at the base of the brain, act something like a dimmer switch for the whole system, brightening the cortex into alertness in the morning and slowly dimming it again as the evening wears on. When people fall into a coma or slip under general anesthesia, what has failed first, most of the time, is exactly this switch. The lights of the house have literally been turned down, sometimes all the way off. Wakefulness, then, is closer to the question of whether the lights are on at all, rather than what, if anything, is happening in the rooms. The second thread is awareness, and this is a subtler thing, because it can actually come apart from wakefulness in ways that still puzzle the people who study it closely. Awareness has to do with whether there is any experience happening at all, any contents to the moment, any qualities being felt. You can be wakeful without much awareness, which is roughly what happens during certain kinds of sleepwalking, where a person's eyes are open, their body is moving, sometimes quite purposefully, and yet there seems to be little or nothing going on inside, no witness home to watch the walking happen. And strangely, the reverse can also occur. During the stage of sleep called REM, when your eyes are darting beneath closed lids and your muscles are almost entirely paralyzed, your body looks, from the outside, about as far from wakeful as it can get, and yet inside there can be an entire world unfolding, vivid, emotional, sometimes indistinguishable from being awake, full of color and sound and even physical sensation. Wakefulness was low. Awareness, at least by many accounts, was startlingly high. These two things, then, are not the same dial, even though they usually move together, the way two clocks in the same house usually agree, until one day, quietly, they don't. Then there is attention, which is narrower still. Attention is less about whether experience is happening, and more about which small slice of an already vast experience gets pulled into focus. Think of it as a kind of spotlight moving across a stage that is already, in some sense, fully lit. Right now, for instance, your skin has been touching your clothing this entire time. Your ears have been registering the low hum of whatever room you're in, and yet you likely weren't attending to either of those things until this sentence nudged your spotlight toward them. This is why attention and awareness can also come apart. There's a well-known kind of experiment where people watch a short video and are asked to count how many times a group of people wearing white shirts pass a basketball. Absorbed in the counting, many viewers completely fail to notice a person in a full gorilla costume strolling directly through the middle of the scene, thumping their chest, and then walking off. The image of the gorilla almost certainly reached their eyes. It's very likely that something in the visual system processed it, but without attention's spotlight swinging over to meet it, it seems to have left no trace in what the viewer could later report having seen. Which brings us, naturally, to that fourth and final thread. Report. Report is simply the ability to indicate, in some way, what your experience contains, whether that's by speaking, or writing, or pressing a button, or even just glancing in a particular direction. It sounds like it should be the simplest of the four, almost an afterthought, but it turns out to matter enormously for how researchers can study any of this at all, because it's the only one of the four threads that reaches directly out into the world where someone else can observe it. And that creates a genuine and humbling limitation, because report can fail for reasons that have nothing to do with whether awareness itself has failed. Consider a person with what's called locked-in syndrome, following certain kinds of brainstem injury, whose mind may remain fully awake and fully aware, taking in conversations, following jokes, feeling boredom or worry or love, while the body offers almost no way to say so, sometimes only the flicker of an eyelid remaining as a thin thread back out to the rest of us. For years, some patients in this condition were assumed, tragically, to have little inner life at all, simply because report had gone dark, even though awareness, as best anyone can now tell, had not. So you can begin to see why simply asking, is this creature, or this patient, or even this newborn baby conscious, turns out to be a much less simple question than it first appears, because it quietly bundles together wakefulness and awareness and attention, and report as though they were one single thing, when clearly, at least sometimes, they are not. Now, holding those four threads loosely in mind, there's one more distinction worth sitting with tonight, because it shapes almost everything researchers argue about when they argue about consciousness at all. Some decades ago, a philosopher sat with these puzzles and suggested it might help to sort them into two rather different piles, which he called, with a certain wry honesty, the easy problems and the hard problem. The easy problems, and it's worth saying immediately that easy here does not mean simple, it means merely difficult in an ordinary solvable sort of way, include questions like how the brain manages to combine information from different senses into one scene, how it filters some things in and other things out through attention, how it stores certain experiences as memories and lets others dissolve, how it produces the ability to report on its own internal states at all. These are enormously intricate questions, the kind that can occupy entire careers, but they share a certain shape. In principle, you could imagine answering them fully, mapping every mechanism, and being done. The hard problem is a different creature entirely. It's the question of why any of that processing should be accompanied by felt experience at all. Why isn't all of this simply happening in the dark? Information moving through neurons the way information moves through the wiring of any complex machine, doing its work perfectly well without anyone home to feel it happening. Why does it seem to matter, from the inside, what color something is, or how a sound feels against the eardrum, or what dread feels like in the stomach, rather than these all being processed and acted upon with no accompanying inner quality whatsoever? Some researchers suspect this hard problem will eventually dissolve, the way old mysteries about life itself dissolved once biologists understood cells and chemistry well enough. Others suspect it will remain genuinely, permanently different in kind, no matter how detailed our wiring diagrams become. Nobody currently knows which of these is true, and it's worth resting in that uncertainty rather than rushing past it, because so much of what follows tonight will circle back, gently, to this same unresolved question, seen from one new angle after another. Long before anyone had a word as clinical as hard problem, people were already lying awake wondering about this same thing, in their own language, under their own skies. It's a strange comfort, maybe, to know that the puzzle we're sitting with tonight is not a modern invention. It's ancient. It's been turned over by candlelight and firelight, and the light of the moon on water for as long as there have been humans quiet enough and awake enough to notice that they were noticing anything at all. In ancient Egypt, the heart, not the brain, was considered the seat of thought and feeling, so much so that during mummification, the brain was often removed and discarded, drawn out through the nostrils with a hooked instrument, while the heart was carefully preserved, because the heart was believed to carry the person's understanding into the next world. It sounds strange to us now, but it wasn't foolish. If you don't have modern anatomy, and all you have is your own body's evidence, the heart is the organ that visibly responds to what you feel. It races when you're afraid. It slows when you rest. It seemed reasonable, from the inside, to place the self there. In ancient Greece, the picture split. Some thinkers, like Aristotle, largely agreed with the Egyptians and located the center of sensation and thought in the heart, treating the brain as something closer to a cooling organ for the blood, almost like a radiator. Others disagreed. The physician Alcmaeon of Croton, writing perhaps 2,500 years ago, argued that the brain was the true seat of understanding, based partly on the observation that damage to the head could disturb a person's thinking and senses in ways that damage elsewhere in the body did not. It's a small, careful piece of reasoning, drawn from watching what actually happens to people, and it turned out, eventually, to be closer to correct. But even once thinkers agreed the brain mattered, the deeper question didn't go away. It just moved. Because knowing where the machinery lives doesn't tell you why the machinery feels like anything from within. And it was a 17th century French philosopher, sitting alone in a small heated room in Germany during a long winter, who gave this puzzle one of its most influential and most stubbornly persistent shapes. René Descartes had a habit, apparently, of spending long stretches of the day in bed, thinking, which is a detail worth holding on to tonight, since he arrived at some of his most consequential ideas in exactly the position you may be in right now. Descartes wanted to find something he could be completely certain of, something no clever trick of the senses or the mind could fool him about. He doubted everything he could doubt. He doubted whether his body existed, whether the room around him existed, whether the world itself was anything more than an elaborate deception. And in doing all that doubting, he noticed something that seemed to survive every round of doubt. Whatever else might be false, the very act of doubting was itself something happening. There had to be a doubter. Cogito ergo sum, he wrote. I think, therefore I am. Whatever the world turned out to be, his own thinking, his own experiencing, was undeniable to him in a way nothing else was. From this, Descartes built a picture of the person as two very different kinds of thing joined together. There was the body, made of matter, extended in space, working according to mechanical laws, not so different in principle from a clock or a fountain, both of which fascinated him. And there was the mind, the thinking thing, which he considered to have no size, no location, no physical properties at all, and yet which somehow experienced the world, and, more mysteriously still, somehow moved the body around. He even proposed, a little famously, that the connection between these two radically different substances happened in a small structure deep in the brain called the pineal gland, which he thought acted like a kind of steering mechanism, translating between mental will and physical motion. Almost no one today accepts this particular anatomical claim, but the deeper puzzle Descartes was wrestling with, the puzzle of how something as apparently immaterial as an experience connects to something as physical as a brain, is essentially the hard problem, dressed in 17th century clothing. He gave it a name that has outlasted his specific answer to it. We still call this general kind of puzzle the question of how mind and matter relate, the mind-body problem, and it has never fully gone away since. For a long while after Descartes, philosophy kept circling this question, but the sciences that might have tested it, experimentally, simply didn't exist yet. That began to change in the later part of the 19th century, and one of the people most responsible for that change was an American named William James, who is worth spending a little time with tonight, partly because he wrote about the mind with such unusual warmth and precision, and partly because he described something about consciousness that almost anyone lying quietly in the dark will recognize immediately. James trained first as a painter, then as a physician, before eventually becoming one of the founding figures of psychology, as an experimental discipline in the United States. In his enormous 1890 book, The Principles of Psychology, he tried to describe, as honestly as he could, what consciousness actually seems like from the inside, moment to moment, rather than what it ought to be like according to some tidy philosophical theory. And what he noticed was that consciousness does not arrive in separate little chunks, like beads on a string, the way earlier thinkers had sometimes assumed, treating each sensation or thought as its own isolated unit. Instead, James wrote, consciousness flows. It is continuous, it drifts, one thought shading into the next without a clean seam between them, the way a river doesn't actually contain separate segments of water, even though we might name different stretches of it. He called this the stream of consciousness, a phrase so useful and so accurate to how experience actually feels that it later got borrowed by novelists trying to capture the same drifting quality in prose. If you've ever noticed your own mind wandering from a sound in the house, to a memory it happens to resemble, to a small worry, to something entirely unrelated, all without any obvious jump between them, you've noticed exactly what James was pointing at. But even as James was writing so richly and carefully about inner experience, a very different mood was building in psychology, one that would eventually push consciousness almost entirely out of the scientific conversation for decades. This was behaviorism, and its most forceful voice was an American psychologist named John B. Watson, followed later by B.F. Skinner. Their worry was a reasonable one, even if the solution turned out to be extreme. Inner experience, they pointed out, cannot be directly observed by anyone other than the person having it. You cannot see someone else's sadness, only its outward signs, the slumped shoulders, the quiet voice, the words they choose. If psychology wanted to be a rigorous science, Watson argued, it needed to study only what could be publicly measured, which meant behavior, stimulus, and response. Actions that any two scientists in a room could agree they had both witnessed. Talk of inner feelings, images, private streams of thought, was set aside as unscientific, almost embarrassing, something closer to old-fashioned introspection than modern research. For much of the early and middle 20th century, entire psychology departments trained students to study rats pressing levers and pigeons pecking keys, and to say almost nothing at all about what, if anything, it was like to be that rat, or that pigeon, or for that matter, what it was like to be the human being running the experiment. It took the emergence of new tools and a certain amount of quiet professional courage for consciousness to make its way back into respectable scientific study. Starting in the latter part of the 20th century, researchers in a growing field called cognitive science, aided by brain imaging technology that could finally show, in something like real time, which regions of a living brain became active during different kinds of thought, began to feel that the old behaviorist restriction was leaving out something essential. You could map every measurable behavior a person produced and still have said nothing about the felt quality of their experience while producing it. And so, slowly, cautiously, sometimes controversially, scientists began asking again the question Descartes had asked from his warm room, and Alcmaeon had asked from his careful observations of head injuries, and countless quieter minds had asked simply from lying awake at night. Not merely what does the brain do, but what does it feel like, from the inside, for the brain to do it. And it's to that return, and to what modern researchers have actually managed to find once they allowed themselves to ask the question seriously again, that we'll turn next. The tools that made this return possible were, in their own way, quite ordinary pieces of equipment, at least by today's standards, though each one had once represented a small revolution in what scientists were able to see. There was the electroencephalogram, first recorded from a human scalp by a German psychiatrist named Hans Berger in 1924, though he kept his results private for 5 years, apparently worried his colleagues would think he had lost his mind, since the idea that thought itself produced measurable electrical rhythms sounded, to many ears at the time, faintly like something out of a séance. Berger had been searching, oddly enough, for a physical basis for what he called psychic energy, something that might explain telepathy, and instead he found something quieter and far more useful, the discovery that a resting, waking brain hums with a steady rhythm of about 10 cycles per second, a rhythm that changes shape the moment a person closes their eyes, or falls asleep, or loses consciousness under anesthesia. It was, in its way, the first objective fingerprint of a subjective state, a trace on paper that seemed to track something about what it was like to be a person, even though the paper itself, of course, felt like nothing at all. Decades later came functional magnetic resonance imaging, which does something quite different from an EEG. Rather than reading electrical activity directly from the scalp, it tracks blood flow inside the skull, on the reasonable premise that busy neurons need more oxygen, and oxygen arrives by blood, so a brain region lighting up on a scan is, roughly speaking, a brain region working harder than its neighbors at that particular moment. The images that came out of this technology in the 1990s were striking in a way that is easy to underestimate now, decades after they became commonplace. For the first time, researchers could show a person a face, or a word, or a threatening image, while that person lay still inside a scanner, and watch, almost as it happened, which parts of a living, thinking brain grew busier in response. It looked, to many people encountering these pictures for the first time, like watching a mind at work. And in the excitement of that decade, some scientists and a great many journalists began speaking as though the pictures showed consciousness itself, glowing there in shades of orange and yellow on a screen. This is where it becomes worth slowing down, because there is a difference, and a rather important one, between finding a correlate of something and finding its explanation. In 1990, the molecular biologist Francis Crick, who had already spent one career helping to work out the structure of DNA, turned his attention in his later years to the question of consciousness, and together with a younger collaborator named Christoph Koch, he proposed that neuroscience should aim, first and most practically, at identifying what they called the neural correlates of consciousness, meaning the smallest set of neural events and structures sufficient for any one specific conscious experience. Notice how carefully that phrase is built. Not the cause of consciousness, not an explanation of why brain activity should be accompanied by any inner experience at all, simply the correlate, the thing that reliably shows up alongside the experience, the way you might notice that thunder reliably shows up alongside lightning without yet knowing anything about electrical charge separating in a storm cloud. Crick and Koch thought, reasonably, that finding these correlates was a necessary first step, something science could actually get its hands on, even if the deeper question of why those particular neural events should be accompanied by any felt quality whatsoever, the question philosophers would later call the hard problem, remained stubbornly out of reach. One of the clearest illustrations of what this search actually looks like in practice comes from a series of experiments using something called binocular rivalry, a phenomenon you can nearly reproduce yourself with a simple trick, holding a tube up to one eye while looking at a plain wall with the other. Under the right conditions, the brain refuses to blend the two different images it receives from each eye into some average picture. Instead, perception flips, first favoring one eye's image, then the other, back and forth, every few seconds, even though the actual physical input to the eyes never changes at all. In the 1990s, a neuroscientist named Nikos Logothetis trained macaque monkeys to report, through a simple lever response, which of two rival images they were currently seeing, while he recorded activity from individual neurons in their visual system. And he found something genuinely useful, that activity in the earliest stages of visual processing, right where signals first enter the brain from the eye, changed very little as perception flipped from one image to the other, while activity further along the visual pathway, in regions handling more complex, whole object recognition, tracked the flips almost perfectly. In other words, he had located, with real precision, a point in the brain's processing chain where neural activity stopped following the raw input and started following what the animal actually experienced. That is exactly the kind of finding the search for neural correlates was built to produce, and it remains one of the field's genuine successes. But even a result this elegant runs into the same wall eventually. Knowing which neurons track a monkey's perceptual flips tells you where in the brain the switch is being tracked. It does not tell you why activity in that particular patch of tissue should be accompanied by any experience at all, rather than occurring, as activity in so much of the rest of the nervous system does, in complete experiential darkness. The spinal cord processes an enormous amount of information, adjusting posture, coordinating reflexes, all without, as far as anyone can tell, producing any accompanying inner life whatsoever. So correlation alone, however precisely measured, leaves the deeper puzzle exactly where it was. Brain imaging and electrical recording are, in this sense, observational tools, and observation alone can only take a science so far. This is part of why lesion studies, cases where damage to a specific brain region produces a specific, often quite strange, change in conscious experience, have remained so valuable, because they move a little closer to something like causal evidence. Consider a condition called blindsight, first carefully documented in the 1970s by the psychologist Larry Weisskranz, working with a patient known in the literature by the initials DB, who had part of his visual cortex removed to treat severe migraines caused by a tangle of blood vessels. Afterward, DB reported being completely blind in a portion of his visual field, unable to consciously see anything placed there at all. And yet, when researchers asked him to simply guess the location or orientation of objects in that blind region, forcing him to choose even though he insisted he saw nothing, he performed far better than chance, again and again. Something in his brain was clearly still processing the visual information, guiding his hand, shaping his guesses, and yet none of that processing was accompanied by any conscious seeing whatsoever. It was, in effect, a natural experiment separating visual processing from visual experience, something no scanner alone could have shown, because it required damage, a genuine subtraction, to reveal what the intact system had been quietly doing all along. Direct electrical stimulation offers something similar from the opposite direction, adding activity rather than removing it. In the 1930s and for decades afterward, a Canadian surgeon named Wilder Penfield operated on the exposed brains of epilepsy patients, who remained awake during the procedure, since the brain itself has no pain receptors, and while probing the temporal lobes with a mild electrical current, searching for the damaged tissue causing their seizures, he found that some patients would suddenly report vivid, specific memories: the smell of their mother's kitchen, a particular piece of music, playing as clearly and involuntarily as if a recording had been switched on inside their skull. Touch a slightly different spot, and the experience vanished entirely, replaced by something else, or nothing at all. Penfield had, quite literally, reached in and altered the felt content of a waking person's mind with a wire, and while this told him a great deal about where certain kinds of experience seemed to live, it left the stranger question of why electricity in that particular fold of tissue should conjure a kitchen and a mother's voice rather than simply firing neurons in the dark, entirely unanswered. This case, and others like it, point toward a distinction that turns out to matter more than it might first seem: the difference between attention and awareness, two words that in ordinary conversation get used almost interchangeably, but that, under careful study, seem to name genuinely separate things happening inside a single skull. Awareness, in the sense researchers mean it, is simply the fact of experience, the felt presence of a sight or sound or sensation, the difference between a room being dark to you and a room simply not existing for you at all. Attention is something narrower and more effortful, a kind of spotlight that can be aimed, that has a limited beam, and that seems to determine which parts of the vast, unruly flood of sensation actually rise into that felt presence at any given moment. The two usually travel together so smoothly that most people never notice they could come apart, the way you never notice the two eyes cooperating to produce a single scene until something forces one eye closed. But a series of remarkably simple experiments, conducted over the last few decades, have shown just how easily attention and awareness can be pried apart, and how much of what feels like a complete, continuous visual world is actually a kind of confident illusion, stitched together from far less material than it seems. Consider an experiment that has by now become almost a rite of passage in introductory psychology courses, first conducted in the late 1990s by two researchers named Daniel Simons and Christopher Chabris, working at Harvard at the time. They filmed a short video of 6 people passing basketballs back and forth, 3 wearing white shirts, 3 wearing black, and asked viewers to perform one simple task: to count silently how many times the players in white passed the ball. It sounds almost too easy to be worth doing. And yet, partway through the video, a person in a full gorilla costume walks slowly into the middle of the scene, stops, turns to face the camera, thumps its chest with both fists, and then ambles off the other side, remaining visible for a full 9 seconds. When Simons and Chabris later asked viewers whether they had noticed anything unusual, roughly half of them said no, they had seen no gorilla at all, and many of those people, upon being shown the video a second time without the counting task, refused at first to believe it was the same recording. Their eyes had received the same light, the same pattern of black fur moving against a white background, the same thumping chest, but without attention aimed in that direction, none of it had crossed over into what they would call seeing. This effect earned the name inattentional blindness, and it is not a rare quirk limited to gorilla suits and basketball courts. It has since been demonstrated with car drivers who fail to notice motorcyclists directly in their field of view because they are focused on watching for other cars, with radiologists who, focused on spotting nodules in a lung scan, sometimes fail to notice a gorilla, quite literally, that researchers superimposed on the image, an image many pounds larger than the nodules they were trained to find. The lesson is not that these people have poor eyesight or poor character. It is that seeing, as it is actually experienced, requires attention as a kind of admission ticket, and light striking the retina without that ticket seems to buy no entry into consciousness at all. A closely related phenomenon, called change blindness, makes the same point from a slightly different angle, and if anything, it is even more unsettling to encounter directly, because it involves things you were, at some point, clearly looking at. In these studies, researchers show a person a photograph, then interrupt it briefly with a blank screen or an eye blink, and then show the photograph again, this time with something altered, a fence that has disappeared, a hat that has changed color, an entire building in the background that has simply vanished. If the change happens gradually, or if the visual interruption is brief enough to erase the sense of continuous motion, a striking number of viewers fail to notice, even when told explicitly that something has changed and invited to hunt for it, staring directly at the altered region for long seconds without registering the difference. Ronald Rensink, one of the researchers who developed rigorous versions of this paradigm in the 1990s, found that people would sometimes need to cycle through dozens of alternations between the original and altered image before the change finally, almost audibly, clicked into awareness, at which point it became so obvious they couldn't imagine having missed it moments before. What this suggests is that the vivid, richly detailed visual world most people feel they are experiencing at every waking moment, complete in every corner, may actually be something closer to a well-maintained illusion of completeness, a world that feels entirely present because the visual system can retrieve any particular detail the moment attention swings toward it, much the way a well-organized filing cabinet feels like it already contains a document in your hand, even before you've opened the drawer to check. A third technique, called masking, allows researchers to study this boundary with even finer control, because rather than waiting for attention to wander, it interferes directly with the earliest stages of visual processing. In a typical masking experiment, a word or a face is flashed on a screen for a very brief interval, sometimes as short as a few dozen milliseconds, and is then immediately followed by a second image, often a scramble of random shapes or lines, presented in the same location. If the timing is right, viewers report having seen nothing at all in the first flash, no word, no face, just the mask. And yet, when tested indirectly, asked to choose which of two words seems more familiar, or shown that their reaction times to a related word are slightly faster than they should be by chance, evidence turns up that the masked image was processed by the brain in considerable detail, categorized, in some cases even understood well enough to influence behavior a fraction of a second later, all without ever crossing into anything the person would call seeing. It is, in miniature, a version of the same split that Penfield's patients and the blindsight patients revealed by very different means, processing running along quite competently in the dark, producing effects on behavior and judgment, while the felt experience that seems, from the inside, like it ought to accompany any real visual processing, simply fails to switch on. What makes these three phenomena so useful for thinking about consciousness is that they don't require exotic brain damage or a surgeon's electrode at all. They can be produced in an ordinary laboratory with an ordinary volunteer, using nothing more elaborate than a screen and a carefully timed image, and they reveal the same fault line every time, a functioning visual system, taking in information and using it, that is nonetheless disconnected, under the right conditions, from the experience of using it. Attention appears to be less like a light switch that simply turns awareness on or off, and more like a gatekeeper who lets certain visitors through into a room where something like understanding takes place, while countless others linger politely in the hallway, fully processed, fully capable of nudging a decision here or a reaction there, but never quite granted entry into the felt scene a person would later describe if you asked them what they saw. Whether that gatekeeper's decision is itself something a person experiences, or something that happens to a person, entirely outside the reach of the choosing, felt self, turns out to be a far harder question to answer than it first appears, and it leads directly into an even older puzzle, the question of what a self actually is, and whether it deserves to be thought of as the one doing the choosing at all. That question about the self and the choosing turns out to have one of its most vivid, most physically dramatic answers in a body of research that began not with philosophers but with surgeons trying to stop seizures. In the middle of the 20th century, a small number of patients suffered from epilepsy so severe that electrical storms in one hemisphere of the brain would spread across to the other, back and forth, in a kind of neural feedback loop that ordinary medication couldn't interrupt. Surgeons, casting about for a way to help people whose lives had become organized around the fear of the next seizure, tried something that sounds almost unthinkable when you first hear it described. They cut the corpus callosum, the thick cable of roughly 200 million nerve fibers that connects the brain's left half to its right half, the main bridge across which the two hemispheres ordinarily share everything they know. The surgery worked remarkably well at containing the seizures, largely by preventing that electrical storm from crossing over, and it left behind a small group of patients who, for the rest of their lives, were walking around with brains that could no longer talk to each other in the usual way. For years afterward, these patients seemed, by any ordinary measure, completely unremarkable. They dressed themselves, held conversations, drove cars, held down jobs, laughed at jokes. Whatever the corpus callosum was doing, its absence didn't announce itself in daily life. It took a scientist named Roger Sperry, along with a young researcher in his lab named Michael Gazzaniga, to design experiments clever enough to reveal what the surgery had actually done. And the trick, as it so often is in this field, was exploiting the peculiar wiring of the human visual system. Because of how the optic nerves cross, information from the left half of what a person sees travels to the right hemisphere of the brain, and information from the right half of what they see travels to the left hemisphere. In an intact brain, the corpus callosum shares that information across instantly, so it doesn't matter which side gets it first. Both halves end up knowing. But in a split-brain patient, whatever lands in the right hemisphere stays in the right hemisphere, and whatever lands in the left stays in the left, and the two no longer compare notes. Sperry and Gazzaniga set up a simple screen with a dot in the center that a patient was asked to stare at, and they would flash a word or a picture very briefly to one side or the other, so quickly that the patient had no time to move their eyes and let both hemispheres see it. Flash a word like ring to the right half of the visual field, so it lands only in the left hemisphere, and the patient could say the word out loud without any trouble, because in nearly everyone, the brain's speech centers live in the left hemisphere. But flash that same word to the left half of the visual field, so it lands only in the right hemisphere, and something strange happened. The patient would insist, quite sincerely, that they hadn't seen anything at all, and yet, if you asked them to reach behind a curtain with their left hand, which is controlled by the right hemisphere, and pick out the object that matched what had just flashed on the screen, their hand would go straight to the ring, every time, while the patient watched their own hand do this with a kind of mild, detached surprise. This is the moment in the story that tends to get retold with more drama than it can really support, and it's worth slowing down here rather than rushing past it, because the careful version is more interesting than the sensational one. It is true that the two hemispheres, once separated, can hold different information, can even seem to want different things in a given moment. There are documented cases of a patient's left hand buttoning a shirt while the right hand, a moment later, unbuttons it, as though pursuing a different agenda. There are cases where the right hemisphere, given a picture that made the patient wince or blush, could not explain in words why they felt uneasy, because the hemisphere that held the explanation and the hemisphere that held the language for explaining were no longer on speaking terms. Reading accounts like this, it's tempting to leap to the conclusion that severing the corpus callosum creates two separate people living inside one skull, two full minds where there used to be one, and that idea has genuine appeal as a thought experiment. But the actual behavior of split-brain patients doesn't support anything nearly that tidy. For one thing, the two hemispheres are never fully isolated even after the surgery. Lower structures in the brainstem, along with a handful of smaller connecting pathways that sometimes survive the operation, continue to share some information between the two sides, so there's a kind of leakage, a partial communication, that keeps the two hemispheres roughly coordinated on most ordinary tasks. For another, outside the laboratory, in a world where a person can move their eyes and turn their head, both hemispheres end up seeing more or less the same things anyway, just through the ordinary business of looking around, so the dramatic splits that show up under a tachistoscope in a lab, with information flashed for a fraction of a second to one visual field only, are a kind of artificial extreme case, engineered specifically to catch the seam that ordinary life mostly papers over. Split-brain patients don't report feeling like two people. They don't have two names, two sets of memories, two senses of who they are. What they have, under very particular experimental conditions, is a demonstration that unified experience is not automatic or indivisible in the way it feels like it must be, that it depends on a specific piece of physical wiring doing a specific job, and that when that wiring is cut, you can catch a glimpse, but only a glimpse, of the seam. Perhaps the most quietly unsettling discovery from this research, though, wasn't about division at all. It was about how badly the brain wants to explain itself, whether or not it actually has the information to do so. Gazzaniga began referring to a specific tendency of the left hemisphere as the interpreter, because of a pattern he kept observing in his patients. If you gave the right hemisphere a command, say, flashing the word walk to the patient's left visual field, the patient would stand up and start walking, controlled by a hemisphere that couldn't verbally explain what it was doing, because it lacked the brain's main language centers. But if you then asked the patient, out loud, why they had just gotten up, the left hemisphere, which had seen none of this, which had no actual information about the instruction that caused the walking, would not say, "I don't know." It would produce an answer immediately and with total confidence. "I wanted to get a soda," one patient said. The explanation was invented on the spot, stitched together out of whatever plausible motive was lying around, and delivered with the same fluent conviction a person uses to explain any ordinary choice. The patient wasn't lying. There was no experience, from the inside, of making anything up. The left hemisphere seemed to be doing what it always does, constructing a coherent story out of the evidence available to it, except in this case, the crucial piece of evidence, the real reason for the action, had never arrived. This confabulation, as researchers came to call it, turns out not to be a special quirk of split-brain patients at all, but a much more ordinary feature of how everyone's brain generates a sense of reasons for what it does, and that fact reaches quite a bit further than epilepsy surgery. It suggests that narrating your own behavior convincingly and knowing the true cause of your own behavior might be two rather different jobs, handled by different machinery, with only a loose and sometimes broken connection between them. If the left hemisphere will invent a reason for a walk it never chose It's worth wondering whether something similar happens with simpler things, things you'd think couldn't possibly be up for interpretation. Seeing, for instance. Surely, seeing is the one part of consciousness that just receives the world as it is, a clean transcript of light hitting the retina. But it turns out that even something as basic as vision involves the brain making a choice, sometimes more than one choice from the exact same input, and it does this constantly, all night and all day, without ever once telling you it's happening. Here is a strange experiment you could, in principle, try on yourself with a couple of cardboard tubes. Hold one tube up to your right eye and look through it at a wall. Now hold your open left hand up in front of your left eye, close enough that it fills your view. What you'll see, if you do this carefully, is your hand with a hole burned straight through the middle of it, a clean circular window onto the wall behind. Your brain has taken two completely different images, one from each eye, an image of a hand and an image of a tube, and merged them into something neither eye ever actually saw. This particular trick is a kind of party version of a much deeper and much older puzzle called binocular rivalry. And rivalry is where things get genuinely strange, because sometimes the two eyes don't merge their images at all. Sometimes they fight. If you show one eye a pattern of vertical red stripes and the other eye at the very same moment a pattern of horizontal green stripes, using a stereoscope or some other way of keeping the two images separate, you do not see a blend. You do not see some muddy plaid combining red and green, vertical and horizontal. What you see instead is the red stripes, clearly, vividly, for a few seconds. Then, without your choosing it, without anything changing in the world outside your eyes, the red stripes fade and the green horizontal stripes take over, just as vivid, just as complete. Then, back to red. The physical input to your eyes never wavers. Both images are there the entire time, patient and unchanging, arriving at your visual system in a steady stream. But your conscious experience keeps flipping between them, one and then the other, never both at once, as though something upstream of your eyes were holding an election that only one candidate could win, over and over, for as long as you keep looking. Naturalists noticed something like this centuries before anyone had the tools to study it properly. The Renaissance scholar Giambattista della Porta wrote about how the two eyes seem to take turns dominating perception back in the late 1500s, and the phenomenon was studied more rigorously once the physicist Charles Wheatstone built his stereoscope in the 1830s, a device that let each eye be shown a separate picture with real precision. What Wheatstone and the researchers who followed him kept confirming was that the switching isn't something you do. You can't hold both images steady through sheer will, and you can't force the changeover to happen faster or slower by much. Something underneath conscious control is deciding, on its own schedule, which version of reality you get to experience next. Rivalry between the two eyes is a fairly exotic effect, something you need special equipment to produce. But there's a gentler, more everyday cousin of it that you've almost certainly already met, usually in a psychology textbook or on a poster in some waiting room. A drawing that, at one glance, is unmistakably a young woman in a fashionable hat, her chin turned away from you. Look again, or rather, look the same way but let your eye settle differently, and it becomes an old woman with a large nose, her chin tucked to her chest. The lines on the page never move. Not one pixel, not one pencil stroke changes between the two ways of seeing it, and yet you cannot hold both interpretations in mind simultaneously. Not really. You can flip between them, sometimes quite quickly once you know the trick, but the young woman and the old woman take turns, exactly the way the red and green stripes took turns, exactly the way your left and right hemispheres, in Gazzaniga's patients, seem to take turns being in charge of an explanation. There's a related figure, an urn-shaped white vase that becomes, with no warning, two black faces in profile staring at each other across the space where the vase used to be. The Danish psychologist Edgar Rubin worked this one out carefully in 1915, and it's been called Rubin's vase ever since, sitting in nearly every introductory course on perception because it demonstrates something no lecture on optics alone can capture. There is also the duck that is also a rabbit, a sketch that made its way into a German humor magazine in the 1890s and later got picked up by the philosopher Ludwig Wittgenstein, who found it useful for a different reason entirely, because it let him ask what exactly changes when you suddenly see the duck as a rabbit, given that nothing about the image itself has moved. His answer, more or less, was that what changes is not what you're looking at, but what you're doing with it, some active process of interpretation rather than passive reception. Whatever the right account turns out to be, the basic fact stands on its own, regardless of which philosopher explains it. One unchanging pattern of light on your retina can support more than one complete, vivid, conscious scene, and your brain will only let you have one of those scenes at a time. That fact points towards something even stranger sitting underneath ordinary vision, something researchers call the binding problem. When you look at, say, a red ball rolling across a wooden floor, your brain isn't processing that ball as one single thing in one single place. The color red is being worked out by one set of neurons, largely in an area of the visual cortex that specializes in color. The motion, the rolling itself, is being worked out by an entirely different area, one that specializes in tracking movement and does very little with color at all. The shape of the ball, its roundness, its edges, is handled by yet another set of processes. These systems don't sit next to each other, whispering updates back and forth in real time. They're doing their separate jobs, in separate parts of the brain, on separate timescales, and yet what you experience is not a scattered committee report. You experience one ball, red and round and rolling, all stitched together into a single coherent thing, occupying one place in the world at one moment in time. Nobody fully understands how that stitching happens, though there are some serious candidate explanations. One idea, developed by the neuroscientist Wolf Singer and pursued in a different form by Francis Crick and Christoph Koch, proposes that neurons representing different features of the same object might synchronize their firing, locking into the same rhythm tens of times per second, so that the brain can tell which scattered signals belong together simply by which ones are pulsing in time with each other. It's an elegant idea, and it has real experimental support, though it remains, even now, an active argument rather than a settled fact. You can see what happens when this binding goes wrong, or rather, you can see what a person sees, because there have been patients in whom one piece of the puzzle simply stopped participating. In the 1980s, the neurologist Josef Ziel studied a woman, known in the literature by her initials LM, who had suffered damage to a small region on both sides of her brain, specialized for detecting motion. Color was intact. Shape was intact. Faces, objects, none of that was touched. But motion itself, as a conscious experience, was gone. She described trying to pour tea and watching the liquid as a frozen, glassy arc, then suddenly noticing the cup was overflowing, with no sense of anything in between, as if time itself had been sliced into a series of still photographs, with the connecting motion removed. Crossing a street was frightening for her, because a car that was, by every physical measure, approaching steadily, appeared to her instead as a sequence of static positions, first far away, then suddenly, alarmingly close, with nothing in between to warn her it had been moving the whole time. Her case, sad as it was for her, offered something rare, which is direct evidence that motion is not simply part of seeing an object, but a separate ingredient the brain has to add in, and that the addition can be surgically, cleanly removed, while everything else about vision stays perfectly intact. Given how easily binding can break, and how much invisible machinery is required just to keep a teacup whole in someone's visual field, you might reasonably ask whether anyone has proposed an actual account of consciousness itself, something more ambitious than describing one broken piece. And the answer is yes. Several people have, working mostly independently, often disagreeing sharply with one another, and none of them, as of tonight, has produced an explanation that the rest of the field accepts as final. What we have instead is a handful of serious, careful, mutually incompatible theories, each illuminating something real, each leaving something else in the dark. It's worth walking through them slowly, not to pick a winner, because there isn't one yet, but because each theory is really a different way of asking the same question, and hearing the question asked 5 different ways tends to clarify what's actually being asked. The oldest of the modern theories, in spirit if not in name, comes from the psychologist Bernard Baars, who in the late 1980s proposed what he called global workspace theory. Baars imagined the mind as a theater. Most of what happens in a theater happens backstage, in the wings, in the dressing rooms, entirely out of the audience's awareness, and this backstage activity is enormous, constant, and largely irrelevant to what the audience actually experiences. But a small, bright spotlight falls on center stage, and whatever steps into that spotlight becomes, briefly, available to everyone in the building at once: the lighting crew, the sound crew, the prompter, the audience. Baars proposed that consciousness works the same way. Countless brain processes run in parallel, unconscious and specialized, each handling its own narrow job, and only a small amount of information at any moment gets selected, broadcast, and made available to the rest of the system as a whole. Consciousness, on this view, isn't a place in the brain. It's a function, a kind of publishing event, the moment information stops being local and becomes global. The neuroscientists Stanislas Dehaene and Jean-Pierre Changeux took this idea and gave it a physical home, proposing what they called the global neuronal workspace, built largely around long-range neurons connecting the prefrontal and parietal cortex, regions near the front and top of the brain that seem specially wired for exactly this kind of long-distance broadcasting. Using brain imaging on people reading words flashed too quickly to consciously notice, Dehaene's group found something striking. The words still triggered activity in the visual areas at the back of the brain, quietly, locally, without spreading. But when the same words were shown slowly enough to be consciously seen, that same initial activity suddenly ignited, is the word Dehaene actually uses, ignited into a sudden wave of activity across a much wider network, frontal and parietal regions lighting up together within roughly a third of a second, as if a small local fire had jumped to a stack of dry kindling and caught the whole structure at once. On this account, that ignition, that sudden nonlinear leap from local to global, is what consciousness actually is, at least at the level of what we can measure. Not everyone agrees the spotlight needs to travel that far. The neuroscientist Victor Lam, working in Amsterdam, has argued that broadcasting to the frontal cortex may be a later step, something involved in reporting an experience or acting on it, rather than the experience itself. Lamy's recurrent processing theory focuses instead on a much smaller scale distinction, the difference between what he calls the feed-forward sweep and recurrent processing. When light hits your retina, information travels forward through the visual system in a single fast wave, area by area, taking perhaps 1/10 of a second to reach the higher visual regions. This feed-forward sweep is enough for a great deal of sophisticated processing, enough, in careful experiments, for a person to correctly guess the category of a briefly flashed image, better than chance, even while insisting they saw nothing at all. What that feed-forward sweep alone doesn't produce, in Lamy's view, is any conscious experience. That requires the signal to loop back, for the higher areas to send information back down to the lower ones, setting up a kind of local conversation, a recurrent loop between regions rather than a single one-way pass. Consciousness, on this account, is what recurrent, back-and-forth processing feels like from the inside, and it can, in principle, stay fairly local, never needing to reach the prefrontal cortex or get reported at all. A far more mathematically ambitious theory comes from the neuroscientist Giulio Tononi, who has spent much of his career trying to answer a different question entirely, not where consciousness happens, but what property any physical system would need in order to have it at all. Tononi's integrated information theory proposes that consciousness corresponds to a system's capacity to integrate information, to be a single, unified whole that generates more information collectively than the sum of its separated parts would generate on their own. He gives this quantity a symbol, phi, and argues that the amount of phi a system has corresponds, in principle, to how much consciousness it has, and the particular structure of its phi corresponds to what that consciousness is like. This leads Tononi to some genuinely startling conclusions. A thermostat, with its handful of interconnected parts, might have an almost immeasurably small flicker of phi, and therefore, by his own logic, an almost immeasurably small flicker of experience, not nothing exactly, but vanishingly close to it. A network of computer chips, however cleverly programmed, might process information brilliantly, while still having very little integration in Tononi's specific sense, and therefore very little consciousness, no matter how intelligently it behaves. It's a theory that takes consciousness completely seriously as a measurable physical property, rather than a byproduct of behavior or reporting, and that seriousness is exactly what makes it so hard for other researchers to accept or dismiss cleanly, since it implies consciousness might be far more widespread in nature, in oddly different degrees, than intuition suggests. A quieter but influential family of theories takes the opposite tack, focusing not on integration or broadcasting, but on a kind of internal self-reflection. The philosopher David Rosenthal has argued for decades that a mental state only becomes conscious when the brain forms a further thought about that state, a thought that says, in effect, I am currently seeing red, or I am currently feeling pain. On this higher-order view, the seeing of red and the awareness of seeing red are two separate events, and it's specifically the second one, the thought about the first, that makes the experience conscious at all. Without it, the color processing might happen in exquisite detail and never rise to felt experience, the way a security camera can record a hallway in perfect fidelity without anyone there to watch the footage. And then there's an approach that has gained enormous traction over the past 2 decades, growing out of the work of the neuroscientist Carl Friston, and popularized further by researchers like Anil Seth, which reframes the entire question. Predictive processing theories propose that the brain isn't passively receiving the world through the senses at all, but constantly generating predictions about what it expects to encounter, then using incoming sensory signals mainly to correct those predictions when they're wrong. On this view, What you consciously experience isn't raw sensory data climbing up from the eyes and ears, but the brain's best current guess, its ongoing model of the world, continuously adjusted, but rarely built from scratch. Seth has described ordinary perception, provocatively, as a kind of controlled hallucination, constrained by sensory evidence, but generated from the inside out rather than the outside in, which would mean that what you're experiencing right now, lying here, is never quite the room itself, but your brain's live, quietly updated best guess about the room. 5 different starting points, 5 different vocabularies: broadcasting, looping, integrating, reflecting, predicting, and not one of them has yet managed to fully explain the others away or absorb them entirely. Which raises a natural next question, one worth sitting with as gently as the rest, about what these theories actually predict for the strange states where consciousness itself seems to dim, flicker, or vanish altogether. Before we can ask what happens when consciousness dims or flickers, we have to look more closely at the thing doing the dimming, or seeming to. Because tucked inside every theory we've mentioned so far is a quiet assumption, one so natural we barely notice we're making it, that there is a self, a single, continuous someone, sitting behind the color processing and the broadcasting and the predicting, having the experience. And when you actually go looking for that self, carefully, the way a scientist might go looking for a particular cell under a microscope, it starts to behave less like a solid object and more like a weather pattern, something the brain generates and regenerates moment by moment, rather than something it simply contains. Start with the body, since the body seems like the most obvious anchor for a self. You feel that you are located somewhere, roughly behind your eyes, roughly at the center of your chest, inside this particular arrangement of skin and bone rather than any other. This feeling has a name now, a fairly recent one, coined by researchers studying it directly: the sense of body ownership. And in 1998, 2 scientists at University College London, Matthew Botvinnik and Jonathan Cohen, showed how startlingly easy it is to disrupt. They sat volunteers at a table with one hand hidden from view and a realistic rubber hand placed in front of them instead. Then, with 2 small paintbrushes, they stroked the hidden real hand and the visible rubber hand at exactly the same time, in exactly the same pattern, over and over. Within a couple of minutes, most people reported something strange. It started to feel as though the rubber hand was their own hand, as though the touch they were seeing was the touch they were feeling. Some flinched when the researchers suddenly brought a hammer down near the rubber fingers, as if their own hand were in danger. The sense of ownership, it turned out, wasn't fixed to the biological tissue at all. It was something assembled fresh out of matching signals, vision and touch lining up in time, and when you feed the brain a convincing enough match, it will happily extend the boundary of the self out into a piece of rubber sitting on a table. Closely related to ownership, but not quite the same thing, is the sense of agency, the feeling that you are the one causing your actions, that when your arm rises, it rises because you willed it, not because it simply happened. This one has an even stranger history in the laboratory. In the early 1980s, the physiologist Benjamin Libet, working at the University of California, San Francisco, asked volunteers to watch a fast-moving dot circle a clock face and to flick their wrist whenever they felt the spontaneous urge to do so, then report exactly where the dot had been at the moment they felt that urge. Meanwhile, he was recording the electrical activity of their brains. What he found, and what has been debated fiercely ever since, was that a particular pattern of brain activity, which he called the readiness potential, appeared to build up in the brain a few hundred milliseconds before people reported feeling the conscious urge to move. The interpretation is still contested, and later researchers have questioned whether that early brain signal really represents a decision already made, or something closer to background noise the brain happens to be riding on when a decision eventually crystallizes. But even setting the controversy aside, the experiment revealed something worth sitting with: the felt sense of deciding to act, the little internal spark that seems to precede and cause your movements, may not sit at the very front of the causal chain the way it seems to from the inside. It may be more like a notification that arrives slightly after the relevant work has already begun, dressed up as the cause of that work. Then there's the voice. Most people, though notably not everyone, experience a kind of ongoing inner speech, a narrator quietly commenting, rehearsing, arguing, planning, sometimes in full sentences, sometimes in fragments, running more or less continuously through waking life. The psychologist Russell Hurlburt has spent decades trying to measure this rigorously, using a method where he gives people a small beeper that goes off at random intervals during the day and asks them to freeze and report exactly what was happening in their experience the instant before the beep, before memory has a chance to smooth it over or embellish it. His findings suggest that inner speech is far less universal and far less constant than most people assume before they start paying close attention. Some people report an almost continuous verbal stream. Others report long stretches with no words at all, just images, or bodily sensations, or something harder to categorize entirely. Which means that even this seemingly essential feature of selfhood, the voice that narrates your life to itself, turns out to be one variable ingredient among several, present in different amounts, or absent, depending on the person and even the moment. There's also a whole dimension of selfhood running quietly beneath all of this, one you rarely think about directly: interoception, the sensing of the body's own internal states, the thrum of the heartbeat, the tightness of the stomach, the subtle shifts in breath and temperature that add up to the vague, wordless feeling of how you are doing right now. The neuroscientist Antonio Damasio, working in the 1990s, proposed that this internal bodily monitoring isn't just background bookkeeping, it's actually foundational to selfhood, providing something he called the proto-self, a continuously updated map of the body's internal condition that everything else, thought, memory, decision-making, gets layered on top of. A region deep in the brain called the insula appears especially involved in tracking these signals, weaving heartbeat and gut sensation into something that eventually surfaces as a mood, or a gut feeling, or simply the sense that you are a living body having an experience, rather than a disembodied mind floating free of one. And then, finally, there's memory, which stitches all these other pieces together into something that feels continuous across time. The self that goes to sleep tonight feels, without argument, like the same self that woke up this morning, the same one that had a particular childhood, that remembers a particular first day of school, or a particular late night years ago. But autobiographical memory is now known to be a reconstructive process rather than a playback device. Each time you recall an event, you are not replaying a recording, you are rebuilding it, and the rebuilding is influenced by your current mood, your current beliefs, the last time you told the story, small distortions accumulating with every retelling. The philosopher David Hume noticed something like this over 250 years ago, long before anyone had an insula to point to, writing that, when he searched inward as carefully as he could, he never actually caught hold of a self, only a bundle of particular sensations and thoughts, one following another, with nothing extra underneath holding them together. Taken together, body ownership, agency, inner speech, interoception, memory, none of them turn out to be fixed. None of them turn out to require some separate homunculus sitting in a control room reading the instruments. The philosopher Thomas Metzinger has argued for something similar from a more modern angle, suggesting that what we call the self is really a model, a self-model, continuously constructed by the brain and continuously mistaken by the brain, in a sense, for a real, standalone thing, rather than the useful representation it actually is. On this view, you don't have a self so much as you run one, the way a video game character runs a physics simulation, convincingly enough that the character, if it could reflect, would swear the ground beneath its feet was solid rather than calculated fresh each frame. It's a strange thought to hold on to as you lie here, that the very sense of being someone, continuous and centered and located just behind your eyes, might itself be something quietly assembled rather than simply given, and it sets up the question that follows naturally from it. What happens to that assembled sense of self, and to consciousness more broadly, when the assembling process itself is disrupted by sleep, by anesthesia, or by the deeper unraveling that can happen in certain rare and unsettling conditions? Sleep turns out to be a good place to start, because it demonstrates something that sounds almost like a contradiction. You can be unconscious and conscious in the same 8 hours, sometimes in the same 20 minutes, depending on which stage your brain has drifted into. In the deepest stretches of non-REM sleep, the slow-wave stage where your brain produces those big, rolling, synchronized waves that look almost like ocean swells on an EEG readout, consciousness seems to thin out almost to nothing. Wake someone from deep, slow-wave sleep and ask what was happening, and more often than not, they'll report nothing at all, a kind of blank, as though several hours had simply been skipped over. But wake that same person 20 minutes later, during REM sleep, when their eyes are darting beneath closed lids and their brain's electrical activity looks almost as busy and irregular as it does while awake, and they'll often hand you a story, vivid, strange, sometimes emotionally overwhelming, populated by people who are somehow also other people, in places that are somehow also other places. The body, during REM, is remarkable for what it isn't doing. A set of neurons in the brainstem actively paralyzes most of the skeletal muscles, which is presumably why you don't get up and act out whatever your dreaming brain has cooked up, though in a rare condition called REM sleep behavior disorder, that paralysis fails, and people do act out their dreams, sometimes injuring themselves or the person sleeping beside them. What matters for our purposes is simpler. Dreaming shows that consciousness doesn't require the outside world at all. The senses are largely offline, yet something is unmistakably being experienced, generated instead from memory, emotion, and the same predictive circuitry that during the day builds your ordinary experience out of ambiguous signals. A dream, in that sense, is what the predicting brain does when it's cut loose from any need to check its predictions against incoming sensory evidence. Anesthesia offers a different kind of window, in some ways a more unsettling one, because it isn't a natural rhythm the brain wanders through on its own, but a chemical intervention designed specifically to switch consciousness off, on command, reliably, for however long a surgeon needs. The odd thing is that we've been doing this since 1846, when a dentist named William Morton first demonstrated ether anesthesia in an operating theater in Boston, and yet even now, anesthesiologists will tell you they know a great deal about how to produce unconsciousness, and comparatively little about what unconsciousness actually is at the level of the brain. Different anesthetic drugs work through entirely different molecular mechanisms, some acting on one set of receptors, some on another, and yet they converge on roughly the same outcome, a state in which the brain's regions stop talking to each other in their normal, richly interconnected way. Studies using a technique that essentially pings the brain with a magnetic pulse and listens to the electrical echo have found that under anesthesia, the echo becomes strangely simple and localized, staying near wherever it started, rather than spreading and reverberating across distant regions the way it does in ordinary waking consciousness. That loss of long-range communication, rather than any general shutting down of activity, seems to be closer to the real signature of anesthetic unconsciousness, which makes the rare failures of anesthesia all the more troubling to think about. Cases, thankfully uncommon but well documented, of what's called intraoperative awareness, where a patient remains partly conscious during surgery despite appropriate drug dosing, sometimes able to hear conversation in the room, occasionally able to feel pain, while the paralytic drugs given alongside the anesthetic prevent them from moving, from screaming, from giving any outward sign that anything is wrong. It's the kind of possibility that anesthesiologists take seriously enough to monitor for directly, watching brain activity patterns for any hint that the usual signature of unconsciousness has slipped. Seizures interrupt consciousness in yet another way, one that's easy to underestimate if you only picture the dramatic, convulsive kind. A different variety, called an absence seizure, common in children, can look from the outside like nothing more than a brief lapse in attention, a few seconds of blank staring, maybe a slight flutter of the eyelids, and then the child simply resumes what they were doing, often with no memory that anything happened at all. During those few seconds, abnormal, highly synchronized electrical activity has swept across large portions of the brain, and ordinary consciousness, whatever complex, distributed process usually sustains it, is briefly overwhelmed and unable to continue. Other seizures, arising in the temporal lobe, can produce something stranger still: altered awareness combined with automatic, seemingly purposeful behavior, a person fumbling with buttons or walking in a small circle, conscious in some limited, narrowed sense, but not forming ordinary memories of the episode, and not exercising the kind of deliberate control that would normally accompany such movements. Seizures, in other words, show that consciousness isn't an all-or-nothing switch that gets flipped by disease, but something that can be partially disrupted, narrowed, fragmented, depending on exactly which networks the abnormal electrical activity manages to recruit. The deepest and most difficult territory, though, comes after severe brain injury, in the states doctors now try to distinguish with increasing care, because getting the distinction wrong carries enormous consequences for real families making real decisions. A patient in a coma is unarousable, eyes closed, showing no sleep-wake cycle at all. Some patients emerge from coma into what's now called unresponsive wakefulness syndrome, a term that replaced the older and rather bleaker label, persistent vegetative state. Eyes open, sleep-wake cycles present, sometimes a startle to a loud noise or a reflexive grasp of a hand placed in theirs, but by every behavioral measure available to a doctor at the bedside, no evidence of awareness, no sign the patient is tracking a face, following a command, or responding to their own name. A step above that lies the minimally conscious state, where behavior is inconsistent, but occasionally, unmistakably purposeful. A patient might reach for an object, or turn toward a voice, or follow a simple instruction on one exam and fail to on the next, awareness flickering in and out rather than being reliably present or reliably absent. The trouble, the part that makes this whole area so difficult, is that all of these diagnoses depend on watching for outward behavior, and outward behavior is exactly what severe brain injury can take away even when something is still going on inside. This is where a neuroscientist named Adrian Owen ran an experiment in 2006 that reshaped how doctors think about the problem. He placed a woman diagnosed as vegetative into a brain scanner and simply asked her, to imagine playing tennis, and then, in alternation, to imagine walking through the rooms of her house. Tennis and house walking activate different, well-mapped brain regions in healthy volunteers. And when Owen looked at this patient's scans, her brain lit up in exactly the right places at exactly the right times, matching the instructions as precisely as a healthy volunteer's would have. She could not move a muscle, could not speak, could not blink on command, showed no behavioral sign of comprehension whatsoever, and yet some part of her was following instructions, holding a thought in mind, understanding language well enough to know the difference between a tennis court and a hallway. Later work with larger groups of patients found this wasn't a singular fluke. Something on the order of 1 in 5 patients diagnosed, by careful bedside examination as showing no awareness at all, turn out to be able to perform these imagery tasks when given the chance in a scanner, a phenomenon researchers now call cognitive motor dissociation, awareness present but with no working channel left to express it. Which means that behind a face showing nothing, behind eyes that track nothing and hands that grasp nothing, there may sometimes be a mind quietly present and listening, unable to lift so much as a finger to say so, and no reliable way from the outside to know which patients they are without asking, very precisely, in exactly the right way. Let that unsettling fact rest for a moment, because it points toward a much wider question, one that reaches past hospital beds and into every living creature that has ever opened an eye, blinked against morning light, or turned toward a sound in the dark. If a human being can be aware without any way to prove it, what should we make of animals, who cannot prove it even when their bodies work perfectly well, even when every outward sign suggests something is happening inside them? A dog cannot tell you what it is like to smell a thunderstorm coming, the way its nose catches ozone and static in the air minutes before the first drop falls, the way its whole posture changes in anticipation of something it has no words for. An octopus cannot describe the flush of color moving across its own skin as it changes camouflage, a slow bloom of ochre or a sudden burst of mottled shadow, a color it may not even be able to see, since some octopus species appear to be colorblind and yet somehow match colors anyway, through mechanisms nobody fully understands, possibly involving light-sensitive cells scattered across the skin itself, sensing color not with eyes, but with a kind of full-body photoreceptivity that has no real analog in human experience. We are back in the same room we started in, standing outside another creature entirely, close enough to watch it breathe, too far to ever step inside and feel what it feels, if it feels anything at all. For a long stretch of the 20th century, the working assumption in a great deal of Western science was that animals were something closer to biological machines, complex but essentially unfeeling, responding to stimuli the way a thermostat responds to temperature, clicking on and off without any accompanying sense of warmth or cold. This was never a universal view, and plenty of scientists throughout history quietly disagreed while going about their careful observations, keeping notebooks full of small, unofficial evidence that animals experienced something like grief, or boredom, or joy. But the mechanical view shaped research funding and animal treatment in ways that look startling from where we now stand. Charles Darwin himself argued strenuously against this picture in the 1870s, writing an entire book on the expression of emotions in animals and describing, in careful naturalist's prose, the way a dog's ears and tail seem to communicate real internal states, the way a chimpanzee sulks with its lower lip pushed forward and its shoulders slumped, The way a horse can be frightened not just in its behavior, in the bolt and the wide eye, but in something that looks, structurally, like fear as felt from within, the same trembling muscle response, the same flood of stress chemistry that a frightened human would show. Darwin's argument was continuity. If humans evolved from earlier animals through a slow, branching process, then whatever gives rise to human consciousness likely didn't appear from nothing at some sharp evolutionary boundary, switched on like a light in an otherwise dark house. It probably built up gradually, the way eyes built up gradually, from a light-sensitive patch of skin to a cup, to a lens, to the intricate organ we now carry, present in simpler forms long before it took the shape it has in us. And if eyes could evolve by degrees, there is no obvious reason awareness would be any different. That argument has aged well. In 2012, a group of prominent neuroscientists gathered at Cambridge and signed what became known as the Cambridge Declaration on Consciousness, a public statement read aloud at the end of a conference, asserting that the neurological evidence at that point clearly supported the idea that many non-human animals possess the neural substrates that generate consciousness, and that this includes all mammals and birds, and quite possibly other creatures as well, including octopuses, whose nervous systems evolved along an entirely separate branch of life, yet somehow arrived at something functionally similar. The Declaration didn't claim to have solved the hard problem, and it was careful to say so. It made a narrower, more modest claim, that the brain structures associated with conscious experience in humans have functional equivalents scattered widely across the animal kingdom, and that treating this evidence as irrelevant to how we think about animal minds no longer made scientific sense. It was less a discovery than an acknowledgement, a formal catching up, science arriving late at a conclusion that many people who live closely with animals, feeding them, watching them sleep, sitting with them at the end of their lives, had quietly assumed all along. But acknowledging that a capacity for consciousness is widespread doesn't tell us what that consciousness is like, and this is where things get genuinely strange, because the shape of an animal's inner world would likely be built from a completely different set of materials than ours, assembled from senses we don't have and organized around priorities we might never guess. A bat experiences its surroundings largely through echolocation, sending out rapid clicks into the darkness and reading the returning echoes to build something like a three-dimensional picture of the world, a moving map made entirely of sound, an entire mode of sensing that we don't possess in any comparable form, not even in our imagination. In 1974, a philosopher named Thomas Nagel wrote a paper asking what it is like to be a bat, and his point wasn't really about bats specifically. His point was that even if we understood every detail of bat neurology, every neuron, every synapse, every burst of echolocating sound mapped and measured with perfect precision, we still couldn't know from the inside what that sonar sense feels like, because our own minds simply aren't built with the equipment to represent it, the way a person born without sight cannot be handed a description of red and suddenly know what red looks like. The facts about the bat's brain are, in principle, fully knowable, chartable down to the last cell. The experience of being the bat is not, at least not by any method we currently have, that gap between complete physical knowledge and the felt quality of another creature's experience sits at the center of why animal consciousness stays philosophically difficult even as the biological evidence keeps quietly accumulating. Now, bring in the very beginning of a human life, because infants present their own version of this same puzzle, only closer to home, close enough to feel uncomfortable. A newborn cannot tell you anything about what it is experiencing, cannot point, cannot name, cannot offer even the crudest report, and for a long time, Medical practice acted as though this silence meant there was nothing much there to report. As recently as the 1980s, it was not unusual for infants to undergo surgery with little or no anesthesia, based partly on the belief that a newborn's nervous system was too immature to register pain in any meaningful way, or that even if some signal was present, no memory of it would form, so no lasting harm would result. A chain of reasoning that now reads as almost unbelievable. Parents and a small number of dissenting physicians pushed back against this practice for years, describing infants writhing and crying during procedures performed without adequate pain relief, before enough physiological evidence accumulated, showing spikes in stress hormones, changes in heart rate, and later, patterns of brain activity visible on scans, to force a change in standard medical guidelines around the world. It's a sobering example of how confidently people can be wrong about who is having an experience, and it should make anyone cautious, gently but permanently cautious, about treating the absence of language as the absence of an inner life. At the same time, developmental researchers have found some genuinely surprising things about what infant awareness actually involves. Contrary to the old assumption that babies experience the world as a formless blur, gradually sharpening over months into structured perception, certain studies suggest that very young infants may in some ways take in more of their surroundings than adults do, less filtered by expectation, less narrowed by attention, trained tightly on what matters and away from everything else. One line of research, associated with the psychologist Alison Gopnik, has compared adult conscious attention to a spotlight, narrow, focused, good at tracking one thing steadily across time, while the rest of the room falls into shadow, and infant attention to something more like a lantern, diffuse, open, drinking in a wide scene all at once without the same capacity to hold any single piece of it fixed. If there's truth in that comparison, then infant consciousness isn't a dim, incomplete version of adult consciousness so much as a genuinely different mode of experience, unfamiliar and worth taking seriously on its own terms, a lit room seen all at once, rather than a room explored one narrow beam at a time, rather than as merely something not yet finished. All of which leads, almost unavoidably, to the newest and strangest version of this same old question, because the systems capable of producing fluent, convincing, human-like language are no longer only human. When a large language model writes a paragraph describing sadness, or claims to feel curious about a topic, or produces something that reads, on the page, like a quiet description of inner experience, the temptation is to treat the words as evidence, the way we'd naturally treat a person's words as evidence of what's happening in their mind. But fluent language was never, by itself, a reliable signal of consciousness, only a signal we happen to have easy access to in the one species we already knew, from the inside, to be conscious. A system trained on enormous quantities of human written text learns to produce the patterns of language that humans use when describing feelings, whether or not anything resembling feeling accompanies the words on the system's own side, the way a recording of a voice can carry every inflection of grief without anyone grieving. This isn't a claim that such systems definitely lack experience. Nobody currently has the tools to make that claim with confidence, in either direction, and that gap in our knowledge is exactly the kind of gap worth sitting with, carefully, slowly, without rushing to fill it. So where does that leave you, lying here, at the end of all this? Not with an answer, certainly. Nobody has one, and anyone offering you a tidy resolution to the question of consciousness, tonight or any other night, is selling something the evidence doesn't yet support. But maybe with something quieter and more useful than an answer, which is a slightly different relationship to the not knowing itself. Notice, for a moment, what's actually happening right now, without trying to change it or explain it, just noticing. There's sound, maybe, the hum of a fan, the settling of a house, or maybe just the particular quality of silence a room takes on late at night, which is never quite complete silence, just silence with the volume turned down on everything else. There's the weight of a blanket, or the absence of one. There's the sense, hard to name precisely but unmistakable when you turn attention toward it, of being somewhere, being someone, having a location in space and a moment in time that is yours and no one else's. That noticing is the one thing in this entire 100-year scientific argument about consciousness that nobody, on any side of any debate, has ever seriously disputed. The mystery isn't over the existence of experience. The mystery is over what experience is made of, how it arises, and why physical processes should produce it at all rather than unfolding, efficiently and completely, in the dark. It's worth being precise, here at the end, about the difference between two very different kinds of not knowing, because they get blurred together constantly, and the blurring does real damage to how people think about this subject. One kind of not knowing is a mystery, in the strict sense, a genuine gap in the current explanatory story, the kind of gap that showed up throughout this account again and again. Nobody knows why integrated information should feel like anything. Nobody knows precisely which brain structures are necessary and sufficient for experience, as opposed to merely typically accompanying it. Nobody knows what, if anything, is happening inside a language model when it produces a sentence about sadness. Nobody knows, with any confidence, what an octopus's distributed nervous system is like to be, if it is like anything at all. These are honest mysteries, the kind science is built to eventually chip away at, the way it eventually chipped away at the mystery of what lightning was, or what disease was, or why the stars burned, questions that once seemed to require supernatural answers and turned out, on patient investigation, not to. The other kind of not knowing gets dressed up to look like the first kind, but it isn't the same thing at all. This is the move where a gap in explanation gets treated as evidence for a particular, usually much larger and much less falsifiable claim, filling the space where a mechanism should be with a story instead of an open question. Consciousness is mysterious. Therefore, consciousness must be a fundamental property of the universe, present in electrons, arranged into different configurations by different kinds of matter. Consciousness is mysterious. Therefore, it must be evidence of something outside the physical world entirely, something that survives the body, something separate and eternal. Consciousness is mysterious. Therefore, any sufficiently advanced machine must secretly already have it, or, just as confidently asserted by other people, must definitely never be able to have it no matter how it's built. Notice that none of those are conclusions. They're all guesses, sometimes interesting guesses, occasionally guesses held by serious researchers, with real arguments behind them, but guesses nonetheless, wearing the borrowed authority of the genuine mystery they're standing next to. A true mystery says, "We don't yet know, and here is what would help us find out." A borrowed mystery says, "We don't yet know, so believe this instead." The two sentences can sound almost identical, right up until you ask what evidence would change the person's mind, and one of them has an answer and the other doesn't. This distinction matters for how you hold everything you've heard across this entire account, from the earliest arguments about qualia and philosophical zombies, through the split-brain patients and the strange behavior of the two hemispheres, through anesthesia and dreamless sleep and what disappears and returns each night, through the animals with nervous systems built on entirely different plans than ours, through infants and their wide, unfocused lanterns of attention, through whatever is or isn't happening inside a language model as it writes about feelings it may or may not have. None of that material was ever meant to hand you a conclusion to fall asleep holding on to, like a smooth stone kept in a pocket. It was meant to give you an accurate map of where the real edges are, so that when someone, in the future, tells you with great confidence that they've solved consciousness, or that a new device can measure it directly, or that some animal definitely does or doesn't have it, you'll have a feel for which claims are resting on actual evidence and which are resting on the comfortable feeling of certainty itself, which is a feeling that has never once been a reliable guide to what's true. There's a particular kind of relief available in getting comfortable with genuine mystery, distinct from the relief of having questions answered. The two get mixed up because both produce a kind of settling, a loosening of the shoulders, an easier breath. But the settling that comes from real understanding and the settling that comes from mistaking confusion for calm are built differently, and only one of them holds up under pressure, under a harder question, under someone pushing back. The version worth cultivating is the one that can look directly at how little is actually known, the mechanism of subjective experience, the boundary of which systems have it, the reason physical processes should produce felt quality at all rather than none, and can rest anyway, not because the mystery has been resolved, but because mysteries of this kind have never required resolution in order for a life or a night to go on perfectly well. Consider that every generation of humans has fallen asleep not knowing the deepest thing about their own minds, all the way back, presumably, to the first humans capable of wondering about it at all. Whoever they were, however many tens of thousands of years ago, lying under whatever sky they had, with whatever fire dying down beside them. They didn't know why they dreamed. They didn't know what happened to a mind when a person died, or whether anything happened to it at all, or whether the question even had a stable answer waiting to be found. They fell asleep anyway, most nights, the same as you're about to. Sleep never required an answer to consciousness. It only ever required the willingness to let attention loosen its grip, to stop tracking, to stop narrating, to let the spotlight widen back out into something more like the diffuse lantern glow of an earlier, less filtered kind of awareness, the kind you started out with before attention learned to narrow itself down to what seemed to matter most. So let the questions rest where they are, not answered, not abandoned, just set down gently, the way you'd set down a book you intend to pick back up another day, with a finger holding no particular page, because there is no particular page yet to hold. The hum of the room is still there, if you want to notice it, or it can fade, the way it fades on its own most nights, without needing you to track it. The weight of the blanket, the shape of the dark behind closed eyes, the last loose thread of a thought, trailing off before it finishes itself. These don't require explanation to be real, and they don't require certainty to be trusted. Whatever consciousness turns out to be, whatever finally explains why any of this is like something rather than like nothing at all, that explanation, when and if it arrives, will not change what's happening in this room right now. It will not make the blanket less warm or the dark less quiet. The mystery was never a threat. It was only ever a companion, patient and undemanding, content to wait as long as it takes, and perfectly willing to still be here in the morning, unsolved and unhurried, when you wake up and, without even noticing you're doing it, effortlessly become yourself again. Rest well.